name's Quentin Eustace. I set out with Sir Arthur Eddington to find evidence of the effects that gravity has on light, predicted by Albert Einstein's theory of general relativity. So the general gist of what we did was that we went to Eddington and dispatched two groups, one to West Africa and another one to Brazil, and to observe a solar eclipse. And the solar eclipse was on May 29th, 1919. And and the reason for that was that only during a solar eclipse could you see the bending of starlight that would be caused by the sun. And so what we did was that we had taken pictures of the solar eclipse when it happened, and then we had cross-referenced it with another picture of the sky to see if the stars' positions had changed at all. And to our surprising and prediction that they did, and Einstein's theory held up in that circumstance. And so ultimately what we were trying to do was to observe any effect that gravity would have on light. And as it happened, we were able to discover that light was in fact affected by gravity. More specifically, the places that we went were Principe, West Africa, a small island off of West Africa, and Sobral, Brazil. It was also an interesting time around the world. World War I had just ended in 1918, and this being the case, a lot of equipment and supplies were still being used in the military and government projects. And so for our group to go out there, it took us 5 months to scrounge up as much as we could, get as much prepared as possible so that we could actually make the expedition and successfully observe the sky when that solar eclipse happened. Ultimately, there was just two groups. There was a group dispatched to Sobral, Brazil, and another one, the one that Eddington went as well, was Principe, West Africa, and that was also the one I went on. And I was in charge of photographing the sky during the solar eclipse, and then I also cross-referenced those photos to determine how much the stars' positions had deviated. I'd say the impact on the physics community from this expedition and from what we discovered was incredibly favorable to Einstein's theory of relativity. Still, not everything has been found out or has been discovered or really concisely proved his theory, but that the evidence that light was being affected by a gravitational field was pretty crucial in at least reinforcing that Einstein got something right, and got something incredibly right, that so much in fact that it would revolutionize physics, revolutionize astrophysics, and how we would think about the universe. Also, just another note on Einstein himself. He was very confident in his theory, and he believed his theory was it could not be debunked in any way. He thought it was the correct way. He even said something along the lines, referring to Eddington at the time, that it didn't even matter if we succeeded in completing, observing those effects, he still thought it was right, and maybe he was right, maybe maybe it doesn't necessarily, but I mean, with what happened and what we observed, I mean, it definitely was in favor of Einstein. Einstein at the time, he wasn't really known by people other than physicists. Physicists knew him very well, but when that came out, and that expedition to West Africa and Brazil, it really cemented his place in history, and also his contribution to physics, which was calculable. Thank you for the interview. Appreciate it.